Okay, let's just dive right into this explainer. Welcome to today's extension seminar on input and output. We're specifically focusing on our grade 7 lesson today, and we're going to solve a totally frustrating trap. It's one that practically every single beginner Python programmer falls into the second they start writing interactive programs. Like, if you've ever tried to ask a user for a number, tried to do a simple bit of math with it, and then just watched your entire program crash and burn in the sea of red error text, well, you're in exactly the right place. We're going to unpack exactly why that happens using the official Python 3.14.7 documentation and, absolutely crucially, how to fix it with some really elegant modern code. So here's our flight plan for today's masterclass. We'll be covering 1. The hidden input trap. 2. Converting text to numbers. 3. Formatting your output. 4. A complete masterclass worked example. And finally, 5. The transfer challenge. Let's jump in.
Starting off with section 1, the hidden input trap.
Let's go right to the scene of the crime. You've almost certainly tried writing code exactly like this. Age equals input, age. I mean, on the surface, it makes perfect sense, right? The program pauses, the user types in their age, let's say they type 12, and they hit enter. You fully expect to be able to just add or subtract from that age right away. You're probably thinking, awesome, I've got the number 12 stored in my variable. But the harsh truth, what you've actually captured is wearing a disguise. The input function has this very specific behavior, and the official Python docs are super clear about this. It strictly reads data as text, nothing else. And this perfectly illustrates the trap we're talking about. In Python, there is a massive, fundamental difference between the string 12, which is literally just text, and the integer 12, which is an actual usable mathematical number. The input function always, and I mean always, returns a string. It's kind of like a photograph of the number 12. Think about it. You can look at a photograph of an apple all day, but you can't eat it. In that exact same way, you can look at the string 12, but you cannot do mathematical addition or multiplication with it. No way. If you try, Python just gets totally confused and crashes. All right, moving on to section 2, converting text to numbers. So to get out of this trap, we obviously need a tool to strip away that text disguise. Luckily, the Python documentation gives us our literal translator for this, the built-in int function. The docs explicitly point out that int takes a string, like quote-unquote 123, and returns its actual numeric value, 123. By taking our raw text input and wrapping it right inside this function, we're explicitly telling Python, hey, listen, I know this looks like text right now, but I promise there are real numbers in there. Please extract them and make them a real integer. But wait, what if your user types in 12.5? Well, an integer is strictly a whole number, so that would definitely cause a problem. While int is absolutely perfect for whole numbers, if we're dealing with things like money or really precise measurements or honestly anything requiring a decimal point, we need a different tool. For that exact scenario, we use the float function. It operates on the exact same principle as int, but it actively preserves those decimal values, which lets us do highly precise arithmetic. Okay, section 3, formatting your output. Now that we can actually do our math safely, we need to dress up those results before we show them. Python's documentation outlines a pretty fascinating evolution of how string formatting has changed over the years. We started with the old way, using the percent operator, sometimes called string interpolation, but honestly that's pretty outdated now. Then came the manual way, using the dot format method. That uses these curly braces to mark where variables should go, but it honestly requires a bit too much extra typing. And finally, we have our modern hero, formatted string literals, or as pretty much all Python developers lovingly call them, f-strings. We're really going to focus on f-strings today because they are just incredibly powerful and super straightforward to use. To use them, you literally just prefix your string with a lowercase or uppercase f right before the quotation mark. That's it. Then you can write your Python variables or expressions directly inside curly braces, right within the text itself. It's a real game changer. It makes your code so much more readable because you can see exactly what variable is going exactly where in the sentence without having to hunt for a list of variables at the end of the line. And check out how f-strings handle things like rounding. The documentation gives this really great example using the mathematical value of pi. If you have a super long decimal, you just add a colon followed by a format specifier inside those same curly braces. By adding this tiny little piece of syntax, .3f, you're telling Python to cleanly round that floating point number to exactly 3 decimal places. So math.py becomes perfectly formatted as 3.142. It is an unbelievable level of control packed into just 3 little characters. Which brings us to section 4,
The masterclass worked example. Let's actually see how this all builds into a complete working script. Here is our proven 4-step procedure for handling user numbers without your program crashing. Whether you're building a simple calculator, a text-based game, or a data entry tool, following these 4 exact steps will make sure your data behaves exactly the way you expect it to. Step 1. We grab the input from the user. We display the prompt, enter a number, and then we just wait. But keep our earlier discussion in mind. That variable, step 1, is currently holding a photograph of a number. It's a pure, raw string. If the user types 5, the step 1 variable holds the text character 5, not the actual mathematical value of 5.
Then, in step 2, we apply our translator. We create a brand new variable, step 2, and we wrap our original text variable right inside the int function. This explicitly translates that string into a mathematical integer. Bam! We've successfully stripped away the text disguise.
Step 3 is where the magic really happens. Because we took the time to do step 2 correctly, we can now safely multiply, divide, add, or subtract. Here, we're taking our real integer and multiplying it by 5. And Python is perfectly happy to do this, because it knows beyond a shadow of a doubt that it's dealing with real mathematical numbers, not text.
Finally, in step 4, we present the result back to the user. We use the print function combined with our shiny new modern f string. Notice that f right there before the quotation mark? We inject our step 3 variable right into the middle of the sentence using curly braces. And we use that special decimal formatting, the :.2f, to ensure that no matter what crazy number the math resulted in, it prints out looking incredibly professional, rounded nicely to exactly 2 decimal places.
And lastly, section 5, the transfer challenge.
So, you now have all the foundational tools you need. But, understanding it in theory is really just the first step. Before you go and open up your IDEs today, I want to leave you with a 2-part challenge to test your newfound Python detective skills. First, take a look back at our 4-step masterclass. What exact behavior or what specific error occurs if step 2, that int conversion, is skipped entirely? And second, how would you extend that little program to ask for a second number, multiply them together, and format that final output? As you code today, ask yourself, what other disguises might human input be wearing? And what other tools does Python have to unmask them? Good luck, and happy coding.